Hello everyone. In this video, we'll talk about how to calculate a battery pack using Microsoft Excel. Okay, so a general basic thing, like for example, I'm just taking two examples over here. Okay, one is the Coke and pouch cell, and the other is the Panasonic cylindrical cell. So if I'm designing a battery pack for a vehicle, and I have to just see that which of my one cell is good for it. Okay, if I'm taking two concepts, like one is pouch cell and the other is a cylindrical cell. So how can I compare these two which are better for my vehicle with having I've calculated the rating, I've calculated the energy consumption, and calculated required voltage I want from the vehicle. On that these parameters, how can I select the cells? Okay. So let's start with this technical sheet I've taken from the manufacturer's website. So the first is that I have two cells. One is the Cochlear lithium ion pouch cell, and the other is Panasonic cylindrical pouch cell. So the model number is SLPB 0800857270. Therefore, Panasonic is UR18650ZTA. Okay. Their nominal voltage is same, that is 3.7 voltage for both of them. The nominal capacity is 26 ampere hour for Coke and pouch cell, but for the Panasonic is 3 ampere hour. So we are having a good amount of capacity in Coke and pouch cell. The nominal energy rating, that is the standard energy rating, is around 95.4 watt hour, and for Panasonic is 11.1 watt hour. So we're getting good amount of uh, energy rating in the Coke and pouch cell. When I talk about the internal resistance, so 1.6 milliohms for that cell. Every battery or cell has its own internal resistance, as we know. So for this, we have 1.6 milliohm, and for Panasonic, it is 45 milliohm. Okay. So now the weight. So the weight of the coke and pouch cell is around 387 grams or 0.387 kgs. And for that, Panasonic is around 49 grams or 50 grams. Okay. So you see how much lightweight the Panasonic cylindrical cell is, and the Kokum is compared around approximately it is 9 times or 8 times heavy. When I talk about the dimensions, so the width is around 10 centimeter or 9.9 mm, and for that, also 99 mm for the width, thickness around 7.9 mm or 8 mm approximately. Then I have the length is around 0.275 or 27.5 centimeter. Now the diameter of the cylindrical cell is around 18.6 mm. Okay, and for that, for the length of the cell is 65.3 mm. Okay, now the gravimetric energy density. So what is this term gravimetric energy density means? So it tells about, like for example, if I'm designing a vehicle, okay, so if I'm designing a two-wheeler and I'm working on the weight reduction program over there. So I have that I want know the capacity of my battery. Okay, if I require around 3 kilowatt hour of battery, 3 kilowatt hour. Okay, but now I want to reduce the battery weight as well. So the gravimetric energy density shows that at 1 kg of weight, how much amount of energy capacity that cell has. Okay, so for that basis, if I talk about if I'm working focus on reducing the weight, so I look for the battery pack which has high number of gravimetric energy density. So as over here, it shows that the coconut ball cell has 249 watt hour per kg, which means that at 1 kg of that whole coconut ball cell, you get in 249 watt hour energy. And similarly, when I talk about this Panasonic cylindrical cell, it is 220. So I'm getting more gravimetric energy density in the coconut pouch cell. Now I talk about the volumetric energy density. It shows that, for example, if I am designing a four-wheeler, okay, a four-wheeler, and it has a boot space over there. And with that boot space, I'm taking a retrofitting vehicle. I have a hatchback or I have a sedan, and I have around, like for a hatchback, I have 200 or 300 liters of space, boot space, and for a sedan, I have 400 to 500. Okay, just a number I'm saying, and I want to place my battery pack over there. So for that, amount of space for if a hatchback, if I talk about 200, 250 liters of space, I'll look for a battery pack which has in that minimum amount of space, it can give me good amount of energy, high number of energy rating. So I look forward for that cell, for that in this minimum volume, I get more amount of energy. So that factor or that unit is called as volumetric energy density. Similarly, for the cocoa pouch cell, we are getting this as 5,73,000 watt hour per meter cube. Okay, so like in 1 meter cube of volume, you're getting this much amount of watt hour of energy, and same it goes with around 6,20,000 I talk about, or 620,000 of uh, watt hour of energy per meter cube, 1 meter cube of volume. I'm getting that much amount of energy rating. So this is so as I see that the Panasonic might be lower in the gravimetric energy density, but it is more profitable or more economic or more it has more pros in as compared to the volumetric energy density. Okay. Now, like this, now I just consider that I'm thinking that my battery energy equals to 30 kilowatt hour. Okay, I'm just assuming over here. Okay, I require my battery nominal voltage equals to around 300 volt. Okay, let's just make this as around 40 kilowatt hour battery. Okay, this is what I require, and my vehicle energy consumption. Okay, I'm just taking it as 160 watt hour per kilometer. So for 1 per kilometer of charge, I'm getting this much amount of energy. Okay, and so if I just talk about if I'm taking this parameter, okay, so and I require if I'm taking this, so it might this get changed. Okay, so what I'm telling is that if I've taken energy consumption over here, okay, and required is that my vehicle should travel uh, required vehicle range, okay, equals to I'm taking as 350 kilometers. Okay, so what my this will be if I talk about this, so this will be like the sum of, okay, or the product of 160 into the range. Okay, 160 into 35,000. So I'll just write it over here. Battery energy equals to 160 into 350 into, I'll just take some depth of discharge as 0.9. Okay, so for that I'm getting is 50.4 kilowatt. So write it over here as 50.4 kilowatt hour. This is what I'm getting is. Okay, so I'm design a battery pack with this. Okay, but if I, okay, so if I'm using this, then I'm getting around this. Okay, now I'll talk about the battery units over here. Okay, so I've calculated that I'm designing my battery pack for energy rating of 50.4 kilowatt hour, and the nominal voltage will be this. Okay, similarly for I'll talk about if I'm taking for Kokum, and then here's the Panasonic. Okay, and I just extend this and this. Okay, number of cells in series. Okay, number of cells in parallel. Okay, then I have nominal, okay, nominal pack voltage, nominal pack capacity, nominal pack energy. Okay, and then I can have the volume of, or I can write mass of battery pack. Okay, let's just start with these parameters. Okay, so for the COChem, I know that right now number of cells in series. Okay, so what we know is that I have 300 over here. Okay, so that will be, if I write, it will be, I write my here, it will be the pack voltage divided by the number of cell voltage. Okay, that will give me 81.18. So I'll just take this as 81. Okay, so 81. Now similarly that will be same with the Panasonic as well, because we have the same amount of voltage over here as well. So if I connect 81 cells in series, so I'll getting this much amount of pack voltage which I require. Okay, a number of cells required in series. Okay, so I just want to know what my battery pack capacity will be. Okay, so I can also write over here battery pack capacity. Okay, that will be around, like for example, what I've taken is the C16 divided by 300. Okay, so 168 ampere hour. Okay, so that will give me this. So 168 ampere hour is the requirement over here. Okay, so I have, so when I want to know the number of cells to be connected in parallel. Okay, so we know when we connect cells in series, so the voltage it adds up. Okay, and the capacity remains the same. Now I want to make sure that I get this amount of capacity. Okay, of my cell ampere hour rating. So for that, when I connect the cells in parallel, so my capacity will be added over there. So for this, I'll just equals to 168 divided by 26. That will give me 6.46. Okay, so I can either use this as 6. Okay, I just see what my that will be, because I cannot use this decimal. I have to use a whole number. Okay, and now when I use this over here, equals to 168 divided by the cell capacity of Panasonic. Okay, so I'm getting 56. So I'm getting a whole number over here. Okay, so now what I'll do is I have to just, for my pack voltage, okay, what my pack voltage is getting. Okay, so that will be equals to 81 into 3.7. So 299.7. That is what I'm getting. 299.7. Okay, so this is what my pack voltage is, and now the energy capacity, nominal pack capacity over here. Okay, so when I talk about this, so this will be around equals to, so what is my I've taken 6 cells in parallel. Okay, so 6 into the capacity of cell. Okay, give me 156 over here, 156 ampere hour. I'll just write, okay, for units. Kilowatt hour. Okay, and simply when I do this over here, so mine will be, I'm taking 56 cells will be connected in parallel and into multiply by the cell capacity. Okay, that will give me 168. Okay, so this is very approx number I'm getting, very good number. Okay, so now I can see that I'm way far as compared to over here. So what I can do is if I make this as 7, okay, so now this has been my change, so it will be 182 capacity. Okay, if I try to make this as around, this all is okay, so I get 182 voltage, and if I use this as, make this as 80. Okay, so this will be, I'll just make this as H3, sorry, it will be H2, yep, be 296. Okay, so now I have to calculate the pack voltage or the energy capacity. Okay, so what I'll do is in kilowatt hour. Okay, so this into this, then divide by 1000, 53.872. Okay, and when I simply do this again, I'll get is this multiply the pack voltage into the pack capacity, okay, divide by 1000 per kilowatt hour. So I'm getting 50.34. Okay, so what my required number is around is 50.4 kilowatt hour. Okay, and I'm getting this around similar somewhere near about this, but I'm getting huge value over here. Okay, so if I change this, if I make this as 6, okay, so it will be 46. If I make this as 82, okay, now 47 near about. Okay, so I might get value of this over here. This is what the most I can use over here. Okay, because I cannot exceed more than that. Okay, I have to maintain something. I have to maintain this as well. If I make this as 7, so I'm getting 55 kilowatt hour rating. Okay, and I'm getting 50 over here. You have to make this as well 303. Okay, so I make this 82. Okay, I just make this equals to 82 into 3.7. Okay, yeah, this is what I'm getting is, okay, around 51 kilowatt hour in this and 55 over here. Okay, and this is the pack I'm getting over here if I use this. So I cannot go minimum this, because if I if I change this to 6, so I'm getting below that, and I cannot use it because I have taken my minimum requirement 50.4 for this amount of vehicle range. Okay, so I have to make sure that this my number is around 7. uh so what my battery pack look like is 7 a module of 7 cells in parallel, and then that one module of that same 82 modules connected in series. That all my pack will look like. And over here I have around like 82 cells in series of connecting strings, and that strings of 82 cells connected in 56 number of parallel, okay, strings over there. Now mass of battery pack. Okay, so I have this and this. Okay, so if I talk about what my mass of battery pack will be, okay, that will be in kg. Okay, so when I talk about this, so what I'll do is that equals to this into this and this into what my weight of the cell was, okay, of Kokum cell. That gives me 222 kgs, okay, of weight. I mean, I do this similar over here, okay. So I'm getting is 82 into mass of the Panasonic cell, okay, 225, okay. So you can see that if I talk about now what my I'll just use this, okay, pack gravimetric energy density, okay. So if I talk about this like in kilowatt hour per kg, okay. So so what I talked about that when I talk about the gravimetric energy density, so it is the watt hour divided by the kg, okay. So if I use this, so that will be equal to this divided by this. So 0.24, and when I similarly do over here, give me equals to divided by this. So you can see I'm getting more amount of gravimetric energy density in the Kokum cell. Okay. Now I'll talk about the volume. Okay, volume of the cell, volume of the pack. Okay, in meter cube. Okay. So these are number of cells. Okay. So for this, my formula will be equals to this into, so this gives me total number of cells, okay, 82 into 7, the matrices or array of the cells, into now the volume. So volume of a that cell will be the width into thickness into the length or the height, okay. So I'll do this, I'll click on the width into the thickness into the length, okay, and that gives me the volume in meter per cube, okay. Now similarly I when I do this over here, okay, so this will give me around 82 into this, okay, this into, now what we're dealing is with the cylindrical, okay, so that will give me pi, okay, pi into 0.4 for the 0.25, 0.25, that we take in diameter over here into the diameter into the diameter into the length. So I've got the pi by 4 d square h, the formula. Okay, so when I've evaluated the volume of the pack, okay, so for that, when I talk about this, so what I'm getting is if I convert them into liters, okay, so volume of the pack in liters, okay, I'll just write L, okay, so I just multiply this by 1000, so I'm getting 123.45, and for here I'm getting 81.4 of space I have, okay, in terms of liters. So if I have like space in boot space, so I can use this like 123.45, okay. So if I from that, if I talk about the pack volumetric energy density, okay, but now I'm using the unit watt hour per liter, not the meter cube, okay, because we're getting a very small value over here. So I'll just use the energy capacity, okay, and I'll use the kilowatt hour, or that will be great, okay. So what my this will be equals to this divided by this, enter, okay, and then this will be this divided by liter, okay. So when I compare the two batteries, okay, so I get that the amount of weight, it's almost have a difference of 3 kilograms over here, okay. I'm getting like this is 3 kilograms lighter as I compare, but also providing like 5 kilowatt hour more energy. So getting me more range over here, okay, for that. But as compared to the volume, so if I have less volume, okay, so like I'll just add this to make this more clear. Yeah, and I'll just highlight these two. Okay, so what happens now? How can I select the battery pack on basis of this? So what I have is that when I talk about the cells I've taken, so the cells number of cells in series is around 82 over here, okay, and then I have the number of cells in parallel will be 7 for Kokum. Similarly for Panasonic will be 82 and then 56 in parallel. I'm getting the same amount of voltage which I require, 300 voltage over here. The pack capacity is 182 and over here is 168. Okay, so less capacity. But even the kilowatt hour energy rating is more in the Kokum cell and around 50.97 in the Panasonic. But the mass is around 3 of difference over here. That is around -3 over here. So it around the same as I call in bulk over there. It will be not, the 3 kg will not make any effect over there. Okay. And but I'm getting more amount of energy rating when I talk about this over here. So I'm getting more amount of gravimetric energy density. So I'm getting for that 3 kgs, I'm also getting extra 5 kilowatt hours. Okay. So my range will be more of the battery, my driving range as compared to that pack. Okay. Now we talk about the volume. Okay. So the space that this battery pack requires 123 liters, and for this is around 81 liters. So it is like almost 50% more as compared to this. Okay, 50% more space will be required for the same battery pack over here. Okay, so if I have less space, so I'll go with this battery pack if I'm designing a hatchback over here. Okay, and I have constraint of spaces there, so I will take this battery pack. But if I'm designing sedan over there, okay, if it's a sedan, so this battery pack is very good because at it has more amount of gravimetric energy density. The volume of pack is 120 liters. Okay, so around like I can say 40 liters of more space will be required over there. If you have space, then this is very better. Okay, and you're getting more amount of energy rating as compared to the other pack of cell. So by this, you have to like see, I didn't take 6 over here because I have to maintain this. I cannot go if I totally if I go this over 6. So my rating around 47 of kilowatt hour rating was coming up over there. That is not required. I have to go like my minimum requirement is 50.4, taking the depth of discharge is 90%. Okay, so that is what I'm taking away. 160 is the watt energy consumption, 350 is the required vehicle range. For that, I'm taking this battery pack. Okay, so for this is how you all can design a battery pack over here. Okay, so on the basis of what your requirement is, you can take two any cell which you're thinking of. Okay, even though I've not included the price as well, you can even take that number of cell for price you're taking over here. Okay, so if I can say that if I have around 8, if I talk about, if for example, if for Panasonic, okay, so number of cells, if I write over here, number of cells. Okay, so for this will be 82 into 7, so 574 cells over here. Okay, and talk about over here, so that will be 82 into 56. So you can see that you have to deal with such high amount of number of cells for designing such a high battery pack. Okay, so this amount of cells you have to like, if what happened with this, like if one cell gets faced, so you have to face many issues regarding that, because for example in a series, like if I'm taking 82 cells in series, so one cell goes off, then your battery pack will get disturbed over there. So that's why such high amount of cell will not be very disregarded. You have to be very perfect sure that your BMS is appropriate, the cell, the battery pack is very rigid and tough, the connections are proper. Okay, and if I talk about the cost, if example, if one cell is around 200 rupees, okay, so that will maintain the cost. I'm just giving an assumption of you. Okay, like you also can do like this. So for this, you can take this 4592 into 200. Okay, so your battery pack costs around 9 lakh 18,000. That will be your battery pack cost. Okay, so I've taken this if it around 100 over here. Okay, if you go for we have around 150 is the good but economic price, so you like 6 lakh 88,000 over here. That's what your sales cost will be, but that is if you take in the cost of uh, when you buy in whole, so you get right. So for that, when you're making a project, if I'm talking about a four-wheel right now, if you're working on a two-wheeler, three-wheeler, okay, so how can deduce the number of cells you want? Okay, if you want that number of cells should be less, so you can go with this pack. You have to see, you can add even the Samsung cell of 18650. What will be that? Just add over here and use this. You can compare the whole sheet over here. Okay, and then compare which cell will be appropriate for you for your rating. Okay, so thank you for being with this session.